Hey guys, this is Jim, KN4YCD, and you're watching FEP Labs Radio. Thanks for stopping by. Today we want to talk about the dBs. It's all about the dBs. There's lots of dBs. There's dBMs, dBWs, dBVs, dB Cooper. One of these things we're not going to talk about. The rest we're going to mention at least a few minutes. Let's jump into this. So what the heck is a dB? dB comes from the Latin word, from two words actually. One is Latin word, one's not. From deci, which is from the Latin word decim, which means 10, and bell from Alexander Graham Bell, hence the word decibel. It's generally written as lowercase d, capital B, because of Alexander Graham Bell. And a dB is a measurement of relative strength, and it can be multiple units. It's the difference or ratio between two signal units. So something that has a signal of 30 dBm and something that has a signal of 10 dBm, there's 20 dB difference. Notice I said dBm and dB both in that sentence. dB is a logarithmic scale, and it's a relative difference. And as you know, as hams, every time you double or half the power level of your transmitter, you add or subtract 3 dB to the power level. So if we have a power level of 30 dB and we double our power level, now we have 33 dB. dB can be used to state the difference between two dBm values in the example I just gave you. So the difference is dB refers to decibels. Decibel reading signifies the amount of increase or decrease in a signal. That's all it is. It's not specifically a unit on its own. You can't convert dB to something because it's not something. It's a dimensionless unit. dBm stands for decibel milliwatts, which is commonly what we refer to in amateur radio when we're talking about dBs and dBms. And sometimes those phrases, those terms get used interchangeably. They're not the same thing. They can be used in the same way in certain contexts, but they don't mean the same thing. dBm stands for decibel milliwatts. It's the amount of power that an antenna or amplifier can produce, or how much signal is present at a site relative to 1 milliwatt. Hence the name dBm, decibel milliwatts. All right? And as I said, they're not the same thing. dB is a measure of relative power. You can't convert it into watts. There is no direct conversion of dB into anything. You can convert dBm into watts, and a dBm value is equal to 10 times the log of the power in milliwatts, and that gives us our dBm value for that power in watts. We can convert it directly into watts. So there's a lot of measurements that are made with the dB prefix. dB Cooper ain't one of them. So dBW is relative to 1 watt. And this is interesting. Look at this. You see on the screen, we have 20 dBW equals 100 watts. 50 dBm equals 100 watts. Why is that? Because dBm is relative to 0.001 watts, and dBW is relative to 1 watt, and there's 2 orders of magnitude difference between a 1 milliwatt and 1 watt. So 50 dBm is 100 watts, and 20 dBW is 100 watts. Interesting, huh? And you can measure a whole ton of other units this way. Common ones that might be used in RF is dBRN, decibel reference noise. That's relative to 1 picowatt. dB microvolt, decibel microvolt relative to 1 microvolt RMS. That's supposed to be a D. dBmV, decibel millivolt, 1 millivolt RMS. Decibel volt, 1 volt RMS. And as I said, there's a whole lot of other units that are appended onto the end of dB to describe those units. Commonly on the internet, you see things with sound measurements, and that's referenced in dB also. That's a whole nother video and way out of the scope of what I know what I'm talking about. And I'm not even entirely sure on this one. All right, so I've got a quick chart I put up here. Across the bottom is the dBm that we're talking about. And then on the vertical axis is the equivalent wattage. Because this is a logarithmic scale, you can see on the far left, there's nothing there. You can't even see it because the value is so small. So at 1 dBm, or excuse me, 0 dBm is equal to 1 milliwatt. 10 dBm is equal to 10 milliwatts. 20 dBm is equal to 100 milliwatts. See the factors of 10? 30 dBm is 1 watt, or 10 times 20 dBm, right? 40 dBm gives us 10 watts. And then finally 50 dBm gives us 100 watts. And you can see there as we go right, the curve sweeps up dramatically. That's because it's a logarithmic scale. Because of the vertical scale on this particular diagram, there's no way to really denote those smaller values on the left side of the chart, but they're there. All right. And then finally, the last thing I wanted to show you guys was this, shamelessly stolen from Wikipedia. And this gives an example value of various things with their power levels listed in dBms, along with the power in watts listed to the right side of it. So if we start down toward the bottom at 37 dBm, that's equal to 5 watts. What is that? That's typically the maximum output power from a handheld radio. Your HT has probably got 37 dBm of output power. For an example, when I tested handheld radios, you'll notice that I had an RF tap on there. The spectrum analyzer I use can only take a maximum input of 20 dBm. Any more than that, and it will potentially smoke it. So that's why I've always got an attenuator on there, is to clamp that signal way down below 20 dBm. You can see that even at 30 dBm, that's one watt, which is more than the spectrum analyzer can handle for input power. As we go up the chart, at 60 dBm, that's typically your microwave oven level of power, 1 kilowatt, a little more. 62 dBm is 1,588 watts, and 1,500 watts being the maximum legal power of a ham radio station. So somewhere between 61 and 62 dBm. That's your maximum legal power. At 80 dBm, we're at 100 kilowatts, which is the typical transmission power of an FM radio station, and it gives that station a 31-mile range. Jumping up on the scale at 296 dBm, that is the total output power of our sun, which is pretty impressive. And finally, at the top, 526 dBm is a black hole collision, the power radiated in gravitational waves, yakety, yakety, yaketa, estimated at 50 times the power output of all the stars in the observable universe. So as you can see, it's a tremendous amount of power. And that's what the dB scale gives us. Because the dB scale is logarithmic and can be applied, wattage is a linear value, dBs are logarithmic value, so it allows us to represent large numbers of watts, for example, in this chart, with a small reasonable value that makes sense. If you tried to write that number, that's 3.6 with 49 zeros after it. So that's ridiculous to try and write. It's ridiculous to try and put in a spreadsheet. It's ridiculous to have to do any operation on that. Yet people have to do those kinds of things. So the dB scale gives us a way to manage those sorts of values at a reasonable level for our poor human brains. And that's about it. dB is relative logarithmic scale for we use it for power, but it can be used for other things. As I said, voltage as well, sound, all sorts of things. In any case, that's all I've got on this particular video today. I hope that you got something out of this, and if you would, smash that thumbs up and make sure you're subscribed to the channel. Ring the bell so you get notified whenever I publish any new content. Thanks, guys. Have a great day. 73.